Hi, my name is Mu Ling Wen. Today we're going to make a presentation about our DP3 report. And in our DP3 presentation, we're going to talk about the overview of DP1 and DP2. And the 3D CAD model in product architecture will also be discussed. In industrial design in assembly time worksheet. And lastly, the economic part will be talking about it. And also the future changes will be discussed at the end of the presentation. DP1 is like the planning phase of the entire project. In this phase, the team create the mission statement and the QFD chart to match with the target specification. Also, we interview several customers and create a customer profile to identify the customer needs. And DP2 is like the middle stage of the entire project. The team create a pattern chart to study for the intellectual property. And the screening and scoring charts are used to discuss the concept generation and selection. Also, failure modes and effects are also analysis. And lastly, we create the cash flow diagram to talk about the investment team will make in the future. By the date of today, which is May 2nd, the Team 22 made the final result presentation in class today. And there are totally 11 tasks and they have been finished completely. This is our 3D CAD model section. We create like 3 different parts. As you can see, the first one is just a tube which can be functioned as an entrance. And the second one is kind of spring launching mechanism, gonna function as a path. And the last one is just the funnel receiver. And the ping pong ball gonna enter the tube from the hole on the side wall, and the motor fin gonna be placed at the bottom of the tube. Once the switch of the motor turns on, the ball gonna be blow up and it's gonna exit from the top hole of the tube. And ideally, the ball gonna land on the path of the launching device. And once the pre-compressed spring release, the ball gonna be shoot toward the final receiver, and the ball gonna just exit onto the ramp. And in product architecture section, we create like 3 different chunks which corresponds with the 3 CAD models we create. And by creating the product architecture, the team is able to visualize the entire structure of the project, and it's really helpful for us to learn what we're gonna expand the entire section, or how we're gonna improve our stations. And next, my teammate Iran, you're gonna talk about the industrial design.
So for the industrial design part, we put ease of maintenance and quality of user interaction as the most important factor, because for the ease of maintenance part, after we install our ERG station, it's going to be very hard for us to actually provide any maintenance job. So we want the actual users to be able to maintain their own stations with some common hand tools. So for the quality of user interaction, our VRG station is targeted as an educational product. It's going to introduce some basic physics concepts. Also, the target customers are mainly high school students, so we want them to learn the physics concepts to put them into reality, to familiarize their knowledge they learn from the lecture. So for the ease of use part, we only give it a medium importance because our product does require the user to read our instruction before they can operate the station. And also for safety, we really want to put safety as our first priority, but for some reason, we have to have the user to read the instruction before they can handle our station. If they don't read our instruction carefully, they could possibly damage our station, and they could possibly hurt themselves. So for the aesthetics, we put product differentiation at medium importance. We really want to make a unique product, but in reality, we have to utilize some functions on the already existing products to make our station more into the protection phase. So for the pride of ownership, we only give it a low importance because our station has a relatively simple design and doesn't require too much knowledge from mechanical engineers. So in future designs, when we get our station a more complicated features, we will require pride of ownership for the engineers to actually develop the complex mechanisms. And so for the team motivation, we only give it a medium importance because some motivation is needed so that we can finish the product on time. We only have a limited time. We have a very tight schedule. So the motivation is for team members to keep up with the plan to finish the station on time. So here we are at discussion of future changes. Our current design does work and it works pretty good, but it's a relatively simple design. Also, many parts are hand-built using different kind of materials. So we want to change that in our future designs. So first of all, we want to improve the spring launching device. Currently, the spring launching device is made of wood and a single spring, and it doesn't work every time. It has a relatively poor reliability. Although we try to mark the point where the spring should be compressed, but when we are actually testing it, it doesn't work every time. Also, we are going to need a new entrance ramp because for our current design, the ping pong ball actually have to enter at a height, but actually the entrance ramp is designed to be to let the ping pong ball enter at a ground level, so we are going to need a new entrance ramp. Furthermore, we are going to need a more powerful electric motor because in our current design, even with the electric motor turning into its maximum power output, the ping pong ball actually won't come out at the top of the pipe. So we have to change it into a more powerful motor. Also, like I just mentioned above, we have to use better materials. Right now we are using PVC pipes and wood. In the future, hopefully we can use more cheaper but more reliable materials. Also, to realize this, we are going to utilize 3D printing to shorten our manufacturing time and to make our station better looking. So in order to do this, we do have a few questions. So how to do 3D modeling? Right now we are already able to do some simple 3D modeling. We can build the 3D models for different parts, for different sub-functions. But later on, we really want to use 3D modeling to construct the entire station and be able to do some testing using the software.
And here, as you can see, is our assembly time worksheet. And all the quantities we actually evaluate based on our physical mockup right now. And as you can see, that there are several unique parts. Because that part is actually depends on the Arduinos that we used, and also the spring system, because this spring is actually we automatically adjust it by our own hands. So we think that is quite unique. And as you can see, that there is a assembly time we use, and the value of that is actually depend on the average time we spend when we're assembling our physical mockup among our groups. And after all the assembling done, the total time we're going to spend is roughly around 4 minutes. And here is the quantity service for our BRG project. We actually interviewed our customers based on the high school students and teachers. And down below, we calculated our quantities for selling just in Virginia. Is roughly around 507 units per year. And that is actually exceed our making time, well, actually based on our currently hand-making design. So we're probably gonna make as much as possible. So the quantity is gonna still be the same as described in our previous report, and it's gonna be 492 units. So, and here is our cost sheet. And this one is actually depends on the material we use, and it actually doesn't change that much. So the cost for each unit and work as a variable cost is still around like $69.91. And here is the cost sheet for assembly. Depending on the time we used, we showed to the audience a little bit. Total cost for assembly is going to be 61 cents. And that is quite small amount of money, but however, if you want to like massive produce, and that would be a great deal for involving into the total cost. So we're probably gonna let our customers to assemble our project. And in addition, I think that is a pretty good way for customers to practice, like especially the young kids, as they can have more hands-on experience on building up the circuit and know how to build up an Arduino Connect controller. And because of the reality situations, we're gonna still use our Model 2 we described in our DP1 report. And this one gonna provide us like more profits because we only gonna provide it, in the current state, we're only gonna provide it like 492 units. So the cash flow chart in the next page is gonna still be the same as we presented in our DP1 report. So the price we're gonna fix, because we still keep the goal in mind that we don't want our customers to like pay a lot of money on it, and that product is actually worth buying. So our price is gonna still like be around $105 per unit, and that is quite reasonable. And here is our cash flow chart. Been discussed in the previous report. That is roughly around like 50% of our profit. So, and at the end, you can see that VTEX can actually receive the interest over $5,000 across 3 years. If we are able to like massive produce our product over like 500 units, we're probably going to switch back our model back to the Model 1, which is a fixed price model. The price is almost the same as our variable price, but it will bring our more profit like in the long run. And also, if we have more profits to have, we actually don't mind to the VTEX to increase our nominal rate and a compounding period for counting the interest of the money we rent. And here comes the conclusion of our final report. Up to now, like Team 22 has already finished up the DP1 overview and DP2 overview. And we already developed the 3D CAD model for our stations. And that is actually a quite good representation and instruction for the, for the manufacturing and operating. And also the assembling time worksheet is actually works quite well, I think, because it actually depends on our real-time experience. Along with the quality analysis, we are able to evaluate our economics, and we already discussed the future change of our product. If that is possible, and we can make our project into a center design, we don't mind like to focus more on building more parts, which is able to interchange with our currently design and make the product more variability. So that's it. Thank you.